And they had a lot of foresight. They hired some of the best engineers, and then they gave them freedom. Sometimes it was, hey, can you go make this thing? And we'd go, fair, if we can make it. And sometimes it was people coming up like, hey, we came up with this idea. We want to see if it would work. And so we had the latitude and the freedom and the resources to try.
Welcome to Hangar X Studios, where former fighter pilot and host John Ramstead takes us on a journey across aerospace as it enters an historic period of innovation and transformation. Our guests include aviation experts, pilots, financiers, military leaders, and innovators of all types. Buckle up for another episode of Hangar X.
Today's episode is brought to you by our platinum sponsor, XTI Aerospace. They are powering the vertical economy, building a long-range VTOL, and you can find more at xtiaerospace.com. Now, please remember to like, comment, and share on this channel, and enjoy today's podcast. Welcome to Hangar X Podcast. This is the place where innovators and creators and aerospace experts and investors come to not only understand what's going on in the market, but to find out what the trends are so you can get to where the puck is going, as the great Wayne Gretzky used to say. And so what we'd love for you to do is please subscribe and like this podcast so you can get updates. You can tell your friends, and you'll get notifications when we get the next podcast episode on. And today is I'm so excited about today with a friend of mine, Alex Williams. First of all, Alex, welcome to the podcast.
Thanks so much, John. Great to be here.
Yes, in a very humble introduction, he said, well, just tell people I'm a technical consultant. So for those of you, Alex has a PhD in mechanical engineering, went to Pratt Whitney, helped them with some incredible breakthroughs, and then, Alex is going to tell this story, was able to go over to Apple Labs and run some labs there that absolutely completely changed his understanding of what's possible in design, and I think speed to market and prototyping, and also just a completely different mindset around engineering of solving problems. And now he's brought this career path back into solving some of the biggest challenges that, as we were talking before we rolled, in aerospace today. And some of that is the future of, we're all seeing about drones and anti-drones, both in the military and in the civilian side of things. As a military, former military man myself and everything going on, there's a big problem around readiness globally and how we're addressing that, the war fighter. And as everybody here knows, there's so many stories about technology that's developed for the military that is our everyday things that we can't even live without, from the microwave to GPS. And those things are happening right now today. And then the other one you talked about too is around air mobility, Alex, and the things that are driving air mobility are, first of all, autonomy, which is something we're going to talk about, but also airspace management, advanced airspace management. And just a little preview for everybody out there, we had Jim Viola on a couple weeks ago from GAMA, General Aviation Manufacturers Association. One of their biggest initiatives is the Modern Skies Initiative that's being adopted by the industry. So we're going to be doing a whole one-day summit with the key players and the most expert voices in that whole space. So stand by for some more information on that. That's going to be coming up. But what I'd like to do, what I don't normally do, Alex, but I think having, our entire audience are people who are aviation enthusiasts. They're from aerospace engineers building airplanes to people that fly them, or people just love what's happening right now in this whole vertical economy, this revolution. But I'd love for you to tell your story of what got you excited about, getting into the engineering field and getting into Pratt Whitney, and then what was that pivot over to Apple Labs? And then from there, I kind of want to bring some things full circle.
Okay. Well, John, it's a real joy to be here with you. And so it started, I knew I wanted to be an engineer since I was a teenager. You could make up a lot of stories as to why, probably just because my uncle was an engineer, and he was the cool uncle. And so I went to Georgia Tech. I studied mechanical engineering, then went on to do a PhD. When I finished that up, I got a job offer from Pratt Whitney up in their main facility in East Hartford, Connecticut. Went up there and joined the combustor technology development group.
Now, were you focused on aerospace, or this was just the best job offer?
No, my PhD was actually in biofuel kinetics. Okay. And so it was really it was very much about statistics and process development. Okay. And it's peripherally related. I knew enough about chemical engineering and chemical reaction processes to join the combustor technology development group. But ultimately, I was brought into that group because of how I how I solve problems and approach things. And so our customers were NASA and the U.S. Air Force, and they would bring us different projects. And these are the things like the Advent program, if you go look that one up, AETD. And so we were, in the combustor group, responsible for delivering the combustor to meet the customer requirements. And so we got to do everything from new materials development and introduction, looking at new cooling technologies, new architectures for fuel efficiency, ultra-low NOx. It was all across the spectrum.
And I would guess, you onboard into a company like Pratt Whitney, and you're actually learning a way of doing things, a mindset, a culture. Yeah. And to you, being a new engineer, like this is normal, right? This is the way we do things. And you're excited to be here because these people they've made some huge breakthroughs. We were talking about before, I've been in some jet engines that were actually Pratt & Whitney engines that had some failures, but they came out with some technology that radically transformed not only the safety but the efficiency of engines. If you can talk a little bit about some of that.
Absolutely.
Because I flew the TF-30 on the F-14, so people might be familiar with that, but I had some serious problems.
TF-30 might not have been the best engine that Pratt & Whitney ever shipped, but
I would concur.
But it's also, for reference, the PT6 is one of the largest volume jet engines in the world. It's a Pratt & Whitney engine in everything from a Pilatus to I can't remember how many platforms.
I probably have 1,000 hours in a PT6, and I've never even had a hiccup.
No, it's a bulletproof engine, right?
Yep.
So yes, maybe the TF-30 wasn't the best one ever. However, you have to remember Pratt & Whitney has been at the cutting edge of technology development in aircraft engines almost since the beginning.
Yep.
And this includes, they created the engine for the SR-71 Blackbird. Mm-hmm. Right. They created the first engine for the F-16 and the F-15. They created the engines, of course, for the F-22 and the F-35. They create the best military engines in the world. And I was brought into that group, right? I got to go and sit elbow to elbow with the people designing the exhaust system on the F-119, which is the engine that goes into the F-22, right? And that's just such a unique experience. Straight out of school, and I'm sitting next to these mostly men, but some women, all incredible engineers. Incredible, and the knowledge base there was just world class. And so those were my peers. Those were my mentors. And coming right out of school, that meant I got to go on a really steep learning curve, which was the best part for me.
Right.
So super steep learning curve, great. Absorbed 50 years of aerospace technology history. I visited the labs where the first commercial single crystal blades were sold. Maybe in commercial, they were originally developed for military applications, but they were a sellable product.
And that was a breakthrough in engine technology at the time.
It was a breakthrough, and it enabled the hot section to get hotter, which from fundamental thermodynamics, it's that delta T you need between the ambient and the peak temp in the engine, which is, and the delta T and the delta P are what determine how much power you're going to get out of that thing.
Yep.
So it was a big deal, and I got to meet researchers, material scientists who'd been there almost 50 years. I mean, these people were living museums in the most positive way of everything was in their head. You wanted to know about how was this alloy developed? How was this coating developed? What is this failure mode? Why does this work this way? Why this process versus that process? It was all there at my request as this junior engineer. So it was a real gift to start there and figure out how does this system work.
So, question in that process, Alex, what did you learn about yourself? Because, getting to know you, you're just intellectually curious, very, very intelligent, but you're also a lifelong learner. But I'm also guessing that in an environment like this, there was also, maybe you felt personally challenged or you wanted to rise. But I'd love to know, what was kind of your experience there?
So I am naturally curious, and I wanted to learn everything I could. Mm-hmm. So when a senior engineer, I learned he had the SR-71 engine manuals in his desk. I was like, let me see it. Right, and I got to flick through this thing, and it was pretty amazing. You learn about this is what the pilots would read. This was the manual handed over to the pilots. This is how your engine works. Mm-hmm. You should know, which is crazy because there was quite nothing quite like it in the world, even since. So it is pretty wild, and just innate curiosity, getting able to go and ask these world class experts, all whatever was on my mind, really, and that was pretty incredible. And then we were doing cutting-edge tech dev for the Air Force and for NASA. The Air Force projects were super fascinating. We worked with the AFRL and some really incredible people there and seeing where do they want the puck to go. Right. They're deciding that.
Yeah, AFRL does some fascinating things, probably none of which you can talk about at this point. But yes. Now, it sounds like this was a lot of great things going on. You're exciting, but then you find yourself at Apple Labs. What created that transition for you?
Yeah, so to clarify, there's no official Apple Labs if people look it up on the web.
Okay.
That's not a thing. I ran research labs within Apple. I was at Pratt Whitney for about 3 years, and then I got a call from a colleague who had left Pratt Whitney as well a year before. And we'd stayed in touch. We were good friends. And he said, hey, you need to apply for this job. And it was to join the materials development group at Apple. So Apple looked out at the landscape of materials and said, well, we don't see exactly what we want to see. And very specifically, Apple obsesses about cosmetics, right?
When you say they didn't see what they wanted, what did they want to see?
They wanted to see people who cared about how materials performed functionally and how they looked cosmetically.
Okay.
And truly, like, there's no one who does it. In the automotive industry, the answer is always paint. There's one answer. In the aircraft industry, the answer is we don't care, right? It's about function over form, and they put paint on top of it. And for most applications, that's fine, right? You only paint an aircraft to the color it needs to be for its functional purpose. Okay, that's fine.
After you throw down the green primer.
Green primer, always.
That's right.
Always.
Yep.
So at Apple, a lot of this started out of solving some specific problems. If you recall, the iPhone 6S launched with the 7000 series aluminum. That was one of the really big achievements of this group. So Apple started pulling some of the best material scientists in the world to come and create an aerospace grade aluminum, which you could also anodize and be cosmetically gorgeous. And by default, and we can get into the chemistry if you care, but by default, there's two. A standard aerospace grade aluminum has too many contaminants in it that will show up in the anodized layer, and it makes it yellow, it makes it gray, it makes it ugly. And so when you look at an Apple product, the finishes are super important. And so Apple spent an incredible amount of money to build a world-class team, to equip them with incredible resources to go create new materials and solve difficult materials problems.
So I just think as a layman, right? You think, I think of some of the, you think of some of the classic airplanes with the aluminum skin that are all shiny.
Yeah.
I mean, they look like a mirror.
Yeah, they're beautiful.
Right? So
They're beautiful.
And a friend of mine restored that. But you know what? You buff it down, then you have to put the layers on it, the clear coat, and then you wax it. But, and then it does really good. Except if you touch it, you're going to have to go buff that out and almost retreat that entire, because that aluminum. So what you're talking about is that, now why did they want to use aluminum? And what were some of the engineering challenges? Because, as a layman, we probably don't understand how big of a task maybe this was.
Sure. So the reason it was aluminum is at that point, you have to look through the evolution of the phone, right? We went to the iPhone and then the 3G, 3GS4, and so on. By the time they got to the Plus phones, if you remember Bendgate, that was a thing. Bendgate was Apple making really big phones that then people sat on and they warped a little.
Oh.
So it was a material strength challenge. Okay, how do you solve that? We need a stronger material. Aluminum is this beautiful material for the same reason it's incredible for aerospace applications. It's great for consumer electronics. It's high strength to weight ratio. And it also has to do with, you can find certainly higher strength to weight materials, but it machines really well. It's very cost effective. With the anodization process, you can imbue color into it by putting dye that penetrates the anodization layer and then sealing that over. And so it's really an incredible material for consumer electronics applications. And that's why Apple really pioneered that space. They probably weren't the first to do it, so don't somebody call me out on it. But Apple pioneered it in terms of making it a mass marketable, beautiful product. So Apple was committed to making these beautiful aluminum products. The MacBooks were already aluminum. The unibody MacBook was this really incredibly rigid premium product. And so Apple was committed to aluminums. It was part of the design aesthetic and the design language. And so we had to make it work and had to come up with stronger solutions. And so that was one of the original products for this materials team. Now, those solutions and the products, we just kept going, right? You bring some of these just incredible people together. Jim Yurko runs that whole organization now. Great. He's a PhD from MIT. I worked for him for a long time. And Jim inherited some of it and then kept building the org. But you look at what was built there. I mean, people like Steve Zadesky, Brian Lynch, Chris Prest, these were the founders of this organization. And they had a lot of foresight. They hired some of the best engineers, and then they gave them freedom. Sometimes it was, hey, can you go make this thing? And we'd go fair if we can make it. And sometimes it was people coming up like, hey, we came up with this idea. We want to see if it would work. And so we had the latitude and the freedom and the resources to try. And that's what made it special.
Yeah, and now you talked about a design language. Mm-hmm. So first of all, what is a design language?
From an industrial design standpoint, a design language is sort of man, I'm going to totally do this disservice to all the industrial designers in the world, but
we're asking for your forgiveness in advance.
Yeah, thank you so much. It's a design language is sort of the colors, the materials, the textures, the shapes that define a product. So if you look across Apple's products, there's a very continuous and consistent design language. You don't look and say, well, that material doesn't belong, that finish doesn't belong, that shape doesn't belong, right? And really great brands do this well. Porsche does this extremely well. You see a 911, that's 50 years old, you know it's a 911. You see a 911 that's brand new, you know it's a 911. They have a shape that is a key part of their design language that is definitive to that product and that brand.
And was there a design language building engines?
I think there actually is unintentionally.
Okay.
Right? Engineers don't consciously typically go out and think about and talk about design language. And again, that's something that made Apple really special. The industrial design group was central to everything Apple did, right? To the point where it made people really uncomfortable. Industrial design could say not good enough. And you think, well, it's the best I've ever done. It's not good enough. The answer is no, it's not good enough. So go figure it out. And that could be about the purity and perfection of a color. Like you take any two random iPhones, get one from Singapore, get one from France, and you pull them next to each other. If they're the same model, those colors are imperceptibly, there's no perceptible difference between them. They're just so darn close. And that's a process control thing, but it's also an obsession about quality. In engines, you obsess about the perfection of the engine for the sake of safety and performance, right? When they fire up an F-119 engine on an F-22, when you look at those in an air show, they do those dead stalls in a vertical and the thing falls like a razor on a razor's edge.
Yeah.
Okay, the pilot also knows when he flicks it up, he's going to get so much thrust that his head's going to snap back. And I don't know, it's probably got to be, you would know, it's probably 6-7 Gs. It's bananas, right?
The first time I saw the F-22 demo, because I'm used to flying the F-14 and I've flown F-14 demos.
Yeah.
I literally thought he'd departed and I was going to watch a mishap and an ejection. It was part of the show.
Part of the show.
I was in absolute awe at what that airplane and that engine, the vectored everything was capable of. I was.
Yeah. And the design.
The only thing I wanted to do was say, "Wish I could fly that someday," but I'm past that point.
Too late.
Yep.
But the design expectation is it's perfect.
Yeah.
Right. It's perfect. It's been manufactured to a standard that's so high. When that pilot flicks the throttle, he's going to get everything that he expected.
Yeah.
Right. And that was, so I wouldn't call that a design language. That's actually a cultural expectation.
Okay.
Because design language usually refers to industrial design, and that's typically not a consideration in engines.
So when you're at Apple, because we were talking before, and I remember over lunch too, you even looked at my Apple Watch, said, "Hey, this is titanium."
That's correct.
And you know what? There's a coating that you helped develop, and then had to go from nothing to scale globally to put a coating on this so that it would, wear.
So it's not a coating.
Okay, it's not a coating.
It's important to acknowledge that. It's
okay,
not a coating.
good.
And that's actually.
But yeah, to finish that story, because that leads to my next question.
Okay, so that's a really important thing for people to understand. There are very few coatings on any of Apple's products. When like the metals, those are inherent, and that was again a part of the culture. And so for the titanium watch, it's a really. In fact, I don't even know if I'm allowed to. I think about how to say this delicately. So when you look at the titanium watch, it doesn't have any coatings. It has a surface treatment that's engineered, and it's engineered for stability. If you just go pick up a random piece of titanium and you grab it, you're going to fingerprint it, and the oils in your skin are going to react and leave a permanent fingerprint of titanium in the titanium.
Oh, permanent.
It's fairly permanent. You could etch it away.
Yeah.
But it's a chemical reaction, and it's because titanium naturally forms several unstable oxides. What's on the Apple Watch is an engineered surface, not a coating, that is incredibly stable. And so
it's a surface that actually becomes part of the metal versus.
Well, it's inherent.
Okay, inherent.
It's inherent.
Okay, now you also talked about the speed at which you iterated, the encouragement to fail, make a mistake.
Yeah.
How fast things move. Because right now the pace of change is increasing, and it's increasing rapidly. I mean, just look at where we are today, even versus 4 years ago, and we look at just where drones have come in. Ukraine brought a lot of that to the front, and all of a sudden there was a place where we could go test. There was offensive and defensive, and I got a unclassified briefing from the Air Force. I did some work with some strategic planning work with a large major command. But the battlefield sniper has now been replaced with the drone operator.
Mm-hmm.
There's a sergeant over there in Ukraine. I think he has over 600 confirmed kills. I mean, that's just kind of terrifying.
Wow.
You hear a drone, all of a sudden you're like, okay, maybe
Yeah.
my time's up here on the battlefield.
Yeah.
Because I've been on the battlefield and that psychological pressure. But anyway, things have happened rapidly. And it sounds like the environment, the culture, the mindset inside of what you were doing at the labs is a much better fit for what we need today versus some of the, I would almost think of that as almost like an agile mindset versus I think a lot of traditional engineering, this waterfall mindset. It's very sequential. It's very milestone based. But could you talk about maybe the differences between the two, the pluses and minuses? I'm not saying one's right or wrong, but they're very different.
Well, I actually believe there's enough difference to say that in most scenarios one is right and one is wrong.
Okay, fair.
But
say more then.
Yeah, so in Pratt Whitney, it embodied the traditional aerospace culture, which you have to realize coming out of the Cold War, everything slowed down. You didn't have a motivation to really go faster. So let's go back into aircraft history. In the 1960s, the SR-71 flew, the Concorde flew, right? The Valkyrie test bomber flew. I think it was the XB-70 or something like that, right? The F-4 came out in the 60s. Let that sink in. SR-71, Mach 3.5, I think, is the top documented speed for that thing. What are we flying today that's that fast? Nothing. Okay? So they did that in the 60s. They had a motivation. They were working fast. Now, we throw away half our budgets on committees. I spend most of my time reporting to the Air Force, not developing anything. I spent most of my time running cover so that the engineers who worked on the projects I was running could just focus on their projects. But you know what? I had to interrupt them to create the slide deck to roll up to my boss, who in a management program had rolled over from an HVAC company within United Technologies, which not a great idea. And then on top of that, then could explain it to him, and then he's going to go and try to explain it to his boss, and it's just roll up to roll up to roll up. That was a huge waste of time. Yes, at Apple we did presentations. Yes, at Apple there was immense accountability. But at Apple the culture was excellence is expected. Don't show up if it's not. Truly. And it burned people out. A lot of people couldn't handle it. I took it for 8 years. I was surprised I made it that long. Excellence is expected. It's a super high bar. On top of that, we would move incredibly fast. We had partners largely in Asia who were moving at an incredible speed. We had some great partners in Switzerland as well and suppliers all over the world for sure. But
what facilitated that velocity?
Well, it starts with culture. It starts with an expectation. And it can lead to burnout for sure. But the other side of it is we were all there to do great work and realize that we were on a really tight cadence to produce. And consumer electronics, particularly phones, if you think about it, I joined in 2014, stayed at Apple until the end of 2022. That was a really heated race. Was Samsung or Apple going to achieve market dominance? Was it going to be Android or was it going to be iOS? It actually was really important to the future of mobile computing as we know it today. I think it's largely settled. The market's very stable. Yes, a few points move here and there, but you have Apple won, more or less. They won the dollars in the war anyways.
Yeah.
Android gets more phones by percentage. Apple gets more dollars. It's a different discussion as to why and how that all panned out. But we knew we were in a race, okay? So it started with culture. And then it changed. It went into tools. It went into workflows. The focus was get work done, right? Yes, we had to ship every product perfect. The level of testing that goes into Apple products, people can't fathom. When an Apple product comes to you, you expect it to be perfect. And you know what? It's almost always perfect. Why? Because the quality control standards are there. The inspection machines are there. I saw these incredible laser metrology machines where they would measure a couple hundred points on an iPhone housing at 100% inspection. That means every single iPhone housing that came off the line got the same multi-point inspection, not your little garage shop multi-point inspection. Someone walked around with a checklist.
And they're not taking randomly 1 out of 20 to do a sample set.
No. There's downsampling for different things, but a lot of things had 100% inspection because perfection is what matters. So that's the cultural side, and then you implement it by going faster.
And that perfection didn't slow things down, though. See, that's kind of, it sounds counterintuitive to me.
It does, but it's raising the bar.
Okay.
We're expected to go fast, and we're expected to perform. Right? If you go to the aerospace industry, drones is one of the few places right now where you have that tension. If the U.S. wants to be competitive in the drone market, we actually have to embrace that as a culture. We need to create companies with that fail fast mindset, right? With this willingness to try, the willingness to crash. And we need to be able to do that even at the big scale. Currently, I've talked to many, many engineers in the certification space, and when I say, you should fly it until it crashes, they panic. They say, no, if we crash, the FAA will stop us. We won't get to fly for a year. And they'll cite an example of someone who that happened to. I don't doubt that that's true. The FAA needs to change. The FAA needs to change and realize that failure is okay when you're testing. Failure is not okay when there's passengers on board, when there's live people on board, right? We need to delineate the two. Now, at Apple, aside from a device exploding, which is a super rare occurrence, Samsung did that. Another discussion as to why their batteries exploded. Apple didn't have those problems for good process control reasons.
Okay.
But we would move really fast. We were resourced to do our best work of our lives. We were resourced to go pull in the experts. The barriers to entry to get help were low. So no one failed because they asked for help and they didn't get it. Right? Things weren't delayed because people failed to ask. Things might be delayed if someone failed to ask for help, but if anyone asked for help, the help was always there. You're never alone. It was an incredible team culture. People were always there to help. People are always there to support. And then if you need the outsized resource, great, go find the world's expert, get them under contract and get to work. And so it was very much a can-do attitude, go figure it out. The we can't or we tried that before, those were basically verboten. Whereas in aerospace, sometimes you'd suggest an idea and they'd say, Rob tried that in 1987. Go talk to Rob. And so then you'd walk across the 1.2
Like, hey,
million.
Robbie,
Yeah.
you got a sec.
Yeah, and walk across the 1.2 million square foot plant to go to this building on the other side to ask Rob, and he would tell you the story of how he ran this test in 87. And somehow that settled it, and you could never discuss it again. Why? Because Rob was more senior than you. To me, that was a really terrible way to solve problems. And yeah, I maybe asked a lot of dumb questions.
This is how I did it, so this is how we do it. Any
Correct.
questions, young man? Okay, good. I got to get back to work.
Correct, and that was the culture.
So the curiosity was almost not there.
There was no room for curiosity. A lot of these guys, they had done incredible work.
Mm-hmm.
That was true. They had done world-class work, and they had set the standard. And that meant that then whatever they said was final. But that stymied a culture of innovation.
Yeah.
And whereas at Apple, there were no sacred cows.
So, yeah, I'm a big fan of No Sacred Cows. So all this experience, in just knowing you, the way your mind works, and what you've also done since Apple. I mean, you've been a consultant for some very unique projects. Some you can talk about, some you can't, some commercial, some government, consulted with the private equity firms, investing in this kind of technology. You really could have done or gone anywhere. What was it about aerospace in this field and the vertical economy that seems like that's really drawn your focus and your attention back right here?
It's the right time. So after seeing the contrast of how things were done at one of the best aerospace companies in the world, and then the other side of seeing how technology development, manufacturing and process development, supply chain development was done at Apple, the best electronics company in the world, I had these just dramatically contrasting experiences. And I'm grateful for all of them, even the bad days, even the really sick days in China. I'm grateful for all of them. But when you step back and say, well, what really matters for the next 50, 100 years for our country?
Yeah.
Well, we actually do need to reindustrialize. We don't need to reindustrialize for the sake of nationalism. We need to reindustrialize for the sake that China has already spent the last 20 to 30 years preparing for decoupling, and they've been reindustrializing. They've been pulling everything back. We're blessed with uranium in the United States. Do we refine any? No. We buy it from abroad. That's a problem. We're blessed with most every natural resource that we need here on this continent. Okay? If you add Mexico and Canada, man, we get close to everything we need.
Yeah.
We should take advantage of that. So it's a time for reindustrialization. That actually requires a lot of new thinking. It requires a lot of fresh thinking. Now, I'm really grateful for the deregulation side of it. I'm really grateful that the Supreme Court has kind of doing a reset on NEPA, some of the environmental protection and review processes. We do need environmental protection review processes, but they need to be defined and they need to stop. Why? Because we need to build. And so we need to build everything from the mining industry and getting that going. And there's some great startups in that space. They need help. They need funding. We need to get to refined materials. And then we need to get all the way through to finished products. And then when you get to that side, it gets to where I get really interested, because the future is actually scary, right? We're seeing the future.
What kind of scary?
It's the future of warfare. It's concerning. It's nothing like we've ever seen. And Niall Ferguson published an article today saying something like, I've seen the future of warfare. And we're not ready for it. And it's true. Ukraine's living in hell. You talked a little about this
Well, it's
earlier.
completely asymmetrical right now.
Yeah, it's asymmetrical. It's you're going outside and people have drone alert beacons trying to detect it, and the thing goes off. You're running for your life. Why? Because anti-drone tech isn't there. So I think anti-drone tech is a huge place we need to be investing in. When China invades Taiwan, you better believe they're going to send so many drones they're uncountable. Are we ready? Is Taiwan ready for that? Probably not.
You could destroy it. Well, look at you can see what the Soviet Union's done to Ukraine with drones. And well, let me ask you a question this way. I think. Let's just say I gave you an unlimited budget.
Yeah.
I stuck you in a lab. You can hire anybody you want.
I like this.
Okay, you like this?
Unlimited budget. It's a good start.
It's actually starting next week. But you know, I just bought my Mega Million Lotto ticket. If I win, I'm setting up your lab.
Thank you.
Drones, anti-drone, readiness. Talked about that, right? Air mobility, right? Autonomy. Where would you start, and what's like coming to your mind? Like, here's the biggest thing that I'd love to tackle, because this is this cascading effect into other solutions that are going to benefit society.
Sure. So there's we'll call it 3 vectors to that.
Okay.
And I know you want 1, but there's 3.
No, I like 3.
The first.
I'm multimodal.
Oh, that's beautiful.
How's that?
You're so versatile, John. So the first one would be autonomy, and this goes from talking to drone experts across the U.S. DJI has some of the best drone control software out there. We don't have anything that's close.
No, we really don't, do we, in the U.S.?
No,
we don't.
As far as I know, I'm not talked to anyone in the space who said we're close. If China is willing to sell us something that's an order of magnitude better than what we have, what do they have that they're not selling us? That's a question. So drone control systems and autonomy, super critical. FAA is doing a really good job starting to make progress in that space in terms of changing the non-line of sight rules or beyond line of sight rules. That's really important. There's a bunch of international companies that are doing really good work in the space. So I would cast the really wide net and figure out what's out there. What can we reshore to the U.S.? Where can we find strategic partnerships? Where can we give the United States a real strategic opportunity advantage? That's vector 1. Vector 2 is anti-drone. And it would, again, same approach. Let's look all over the world. Let's look at the United States. Look, actually go and dig in what's Israel doing. What is being developed on the front lines of Ukraine? What would they do if they had the funding to do it? And then go figure out how do we make those solutions a reality, both for the sake of Ukraine, but for the future conflicts. Okay?
And test and iterate and prototype and crash it and kill it. And
we're going to get there.
And get something out there in 3 or 6 months, even if it's MVP.
Yes, so
but let's put it out there. It's going to save a life.
Yeah, you're identifying the opportunities,
Yep.
and then you're partnering with them to give them the capital and the resources. It's building the infrastructure for rapid iteration and test. Right? The idea of, we're waiting on a part, it's going to be 4 months, wrong answer. Right? We've got to figure out what's another way to test this. Do we just need to develop it ourselves? Do we need to build it ourselves?
Yeah.
Right? And to get to those rapid iteration cycles. And so, yes, it's equipping inventors and companies with partnerships, with funding, with executive guidance and coaching sometimes just to keep them going in the right direction.
Yep.
And also to develop those strategic partnerships. Right? We have a lot of companies doing really great work, but they're developing them in silos. What would it look like if they actually had the partnerships? There's a huge number of aerospace technology companies out there who they just need to test. They need a test. They need a flying test bed. They need to get the validation that it works, and they need to do it in a relevant environment. Great. We'd actually love to partner with them and be that partner to get things tested in a test bed in a relevant environment to fly it. So then they can go back to their customer or their next customer or the U.S. government and say, hey, look, we flew it. Why? Because we have to advance U.S. aviation technologies. It can't just be about what one company does. It actually needs to be about what the industry does.
Yeah, I love that collaboration. So vector 1, autonomy. Number 2, anti-drone.
Yep.
Third?
The third vector would actually be supporting and shoring up the re-industrialization in the United States. Right? So you talk to people who are getting transmissions for aircraft, and the things they complain about are actually some of the most frustrating things to hear. They say, our bearings are our longest lead time.
You know, we interviewed Jason Hill from Hill Helicopter.
Yeah.
And just the bearings for his helicopter, and he only needs, if I remember, I think it was 5 or 6 per helicopter. With such a long lead time, it would have actually killed the entire project. So you know what he did? Created his own foundry. And he's going to now, in parallel with building the airplane, he's building an engine and a foundry just to create bearings, which will probably be a great profit center. But he literally couldn't find it in the Western world.
Yeah, and this is a big gap. That's actually a strategic vulnerability. You cannot stand up a bearing factory in a week. You cannot do it in a month. It takes time. right? There's a lot of skill involved in just the quality control and sorting process to have an aerospace grade bearing, right? This is a difficult problem. It's a solved problem, but it's a difficult
I
problem.
mean, it's just a big BB, isn't it? It's pretty simple.
No, John, it's a super precise BB. And if you go to a bearing factory, what they'll actually do is they're going to grind the races, so the cylindrical parts, and they'll grind the balls, and they'll actually inspect optically 100%, and they bin them. And then they do tolerance stack up and match up so that when you pack all the balls in, you have balls and races that match so that you get the specified bearing that you paid for. So
yes, I knew you were going to give me a good answer.
it's just a BB. It's a really precise, well-studied BB that's sorted and paired up with its twins to create a perfect product.
And it's not cheap either.
It's not.
Imagine if we could, actually, it is just that, if you could even buy them commercially, those small number of bearings, is a significant cost of the entire helicopter.
Yeah, yeah.
So imagine, in some of this reindustrialization, if we also start lowering some of the cost of these key components or some of these things that are going into drones, and all of a sudden the $8,000 drone, $10,000 drone is now a $200 or $300 drone in 5-10 years.
And that's where you have to go back and say, why did Apple succeed in building its supply chain in China? Well, it's because China showed up to help. Now, if you read the book Apple in China, I think they do a good job laying out nefariously why China wanted to help. It was about industrializing China and transferring knowledge. But the U.S. government doesn't show up to help, right? It's a joke. People say, well, I'm from the government, I'm here to help. Those are like some of the worst words you could ever hear next to I'm from the IRS and I'd like to see your taxes. So, God willing, I never hear any of those phrases, but the government needs to show up to help. And that's everything from the Environmental Protection Agency realizing it's here to serve the United States, not here to serve some fringe environmentalist agenda, to U.S. landowners actually stepping up and leasing and making their assets available, to states accelerating and allowing permitting so that mines can be stood up, so that factories can stood up. And we have to do in parallel, we have to stand up more power plants. We have to stand up more power transmission. But you realize what all this does, this actually creates a lot of really great jobs. This creates a lot of really good things that serve average blue-collar people.
Which is also going to counteract, because these are the kind of jobs that AI is not going to replace.
No, these are
great
AI
jobs.
resilient jobs for sure.
Yeah.
For sure. And that's what we need. And so the third pillar that I would pursue, if I have infinite resources, it's supporting reindustrialization. Part of that's going to be partnering with manufacturers to help them be more efficient. Part of it might be acquiring them and reforming them. Why? Because we have an incredible industrial base. We had an incredible industrial base. We still have pieces of that. Let's not let that fade away. Yeah. Let's actually take these businesses, let's revive them. Let's change their culture. Let's change how they do everything from acquisition to paperwork to data management, quality control systems. Like, there's actually a lot to be learned. I got to spend time in some of the most advanced factories in the world as I went to Switzerland and saw these incredibly intricate, high quality PVD machine tools were made.
I bet you were fascinated.
Oh, I was geeking out with these guys.
Kid in the candy store.
I loved it. I loved it. I'd spend several days there and just ask question after question. I loved it, right? So I've seen how the Swiss do it, and they're shipping these super high value machine tools, down to going to England and working with some incredible autonomy companies and autonomous laboratory work. There's so much to be learned. There's so much that can be done. We can do better, and by doing better, we'll drive costs down. By doing better, we'll increase efficiency. And by doing better, we'll create a lot of really good jobs.
So I want to end with this and kind of tap into the sage, the wisdom part of your brain. Because you've seen companies from components through, manufacturing of piecing apart an engine to an entire aircraft in assembly. And you've seen engineering teams, right? The thing is, a lot of the experience that we have in aerospace are some of these folks that came up through Pratt Whitney and Lockheed Martin and Sikorsky and so on. And they were kind of trained this traditional way. And then you have these companies that want to, and they want to move fast. And I think there's been a kind of a mix of cultures. If you were, let's say people listening out there, they're the CEO, they're the chief engineer, and maybe they're frustrated with their pace, with, how they're iterating, how people are, approaching being innovative or creative or risk. What advice would you give some of these leaders of these engineering teams that want to get to results faster because it's critical for that to happen for their business to succeed?
Great question. It starts with culture, and the culture has to embrace failure as an okay thing. Right? You actually have to be okay with failure, and that has to go all the way up to the executive level. right? Because it doesn't work if the director embraces failure and they run tests and stuff starts breaking and a VP freaks out because they're afraid there's going to be bad PR. Wrong answer. SpaceX had no fear of failure and no fear of bad PR. Bad PR to them was we never got Starship launched and back. So they failed, I think, 9 times. Maybe it was the 9th or 10th time they succeeded. That's incredible.
And every failure they learned from, it's why they actually got the 10th one launched.
Yeah.
And they almost went out of business doing it.
Sure. It was a huge risk. It was a huge risk, but you have to be willing to take risk. And it's part of it is actually culturally accepting as Americans that succeeding as a country is more important than protecting my job. So that's important culturally. That'll actually shift our public company cultures. That'd be really important.
Yep.
So one, you have to embrace failure. It has to be an okay part of the culture. The other part of it is realizing the people with all the experience should be leveraged for their wisdom and experience. But they absolutely cannot be in the position to keep hitting the stop button. Right?
Like, hey, this is the way we do it. Just stop bothering me.
Right. And the Boom CEO, I've drawn a blank on
Blake
his name.
Scholl.
Blake Scholl, thank you. He did a podcast recently, and it was so great how he articulated. He said, look, we went and hired all of these experts and these seasoned people from all the big aerospace companies, and it went terrible. So then he says the other side, they went back and they hired all these really young guys and girls and these young engineers, and they fixed a lot of the problems and they created a bunch of new problems.
It's just as terrible, but different.
It wasn't, but it didn't sound like it was just as terrible. It was better, but not there yet.
Right.
And where was the sweet sauce? You had to bring back the wisdom.
You had to bring
Wisdom's there
both
for a
groups
reason.
together.
Look, when people, I would love to see senior aerospace engineers moving not into retirement, but moving into mentorship, moving into coaching and advising. Why? Because, gosh, if these guys were actually the ones, and there are almost all men, if they're old and they're in aerospace, it's just the demographic. But these folks, they did incredible things.
Well, and they've been there, they've done that, they've solved the problems, they've used the tools.
Yep.
And then, you know what, you're infusing that wisdom into somebody who has a different approach. They're willing to maybe fail faster, a different way to do it. And all of a sudden you combine these two. We were actually talking to, who was it? I can't remember the name of the company, aerospace company, but that's what they found. Their secret to success was creating this culture where the young group was influencing, I think the speed of the older group. And the older group was mentoring and giving some of the wisdom to the young group. And it was that synergy of these generational workforce, when led right with the right culture, was their key to success. And I know it's going to come to me probably as soon as we wrap, the name of that CEO that we had on. But he said that was the key for them to start moving forward.
And I think that's a general model.
Great takeaway.
And there's not a template, right? It's not a 80-20 ratio.
And there's not a handbook on how to do that well. But it's going to take some time,
but
like everything else.
You have to start by wanting to change and being willing to fail and getting it all the way up to the CEO and having the support of the board, right? You actually need that in publicly traded companies. You need that level of support. If you can get that level of support, and the people who have the most control in publicly traded companies and private companies generally are old. Okay? That's just the truth. That's the way it works, because they've been in the company long enough and they climbed the ladder and blah, blah, blah. That's fine. But they have to be the ones to be willing to fail and let go. And that's one of the hard parts.
Yeah.
Because they have the most to lose. CEO turnover rates are incredibly high in publicly traded companies. They have the most to lose, and the board's willing to replace them. So we've got to change culture around that.
Yeah. Well, let's do this as we wrap up. What are you working on now, or what are you working on next? Like, what's right in front of you?
One of the things I'm working on right now is called Dark Star Laboratories.
Dark Star Laboratories.
Yeah.
All right. I want to hear. Tell me about Dark Star Laboratories.
Can't do that yet, John. We're still in stealth.
Okay.
But we're excited to talk about it publicly, maybe in a few months. We'll see.
Can we have you back on as soon as you can talk about Dark Star?
Would love it.
All right, and I'm gonna go buy you a beer, and I want to hear all about it.
Maybe.
I promise not to talk about it publicly. All right, Alex, thank you for being on. This was fascinating, and everybody out there listening, I just hope you saw the passion, and this passion is across this country. There's thousands, probably tens of thousands of people in this space right now that share this passion. They're going to be changing the world, making things better. But, it's also, I love what you said, Alex. It's also about us learning how to work together, to collaborate, to communicate, to have partnerships, because if we do some of these in a silo versus start to open up and work together, there's so many more. the problems we could solve. There's so much
Yeah.
revenue and opportunity out there. Everybody's going to benefit. Let's get
right.
there faster, because then we also are benefiting the communities that we serve. You know, the people right here. You know, the
right.
jobs locally. The people on the front line somewhere someday. We don't
right.
know. Or the person that needs a heart transplant. But now all of a sudden, like, actually, we just interviewed somebody from Speedbird. Because of the BV loss rules in Israel, they're actually able to do line of sight commercial autonomous
huge.
drones,
Huge.
and they're saving lives because they're
That's
using drones for organ transfer
I love
from up into the back, the where the front lines are. So, and that's just one little part of their story. But we're hearing more and more incredible things happening, and
John,
it's going to accelerate.
One of my earliest jobs was a baggage handler at ASA Delta Connection.
Okay.
And we were always reminded as we loaded we would get these foam freezer boxes. We'd load them on the plane. That is the most valuable thing on the plane. And it's true, because that box was going to save somebody's life.
It's an organ transplant.
So yes, what does the future of autonomy give us in drones? It's not about Amazon package deliveries. Couldn't care less. Same day, next
Amazon
day
will
deliveries,
benefit,
good
but
enough
couldn't
already.
care less.
But
Yeah.
I couldn't care less. What I care about is, great, there's an organ donor in Phoenix, Arizona, but you got to get it to Tucson. You got to get it to Flagstaff. What's the fastest way to do it? It's to fly. So get that thing on a drone and get it out now, right? Because some kid's going to live.
Yep.
And that's what matters.
Or not live.
if you don't do it.
It literally is.
Yeah, it's life or death.
That weighty.
It's
Yeah.
life or death. And so these are the fruit. There's fruit, and there's fruit for the industry. I think you're totally right. We need to work collaboratively. We have to figure out how do we shift that culture in the United States. There's improving in the aerospace industry. It needs to open wide up. The
Yep.
door's cracked open. The door needs to open wide up. Why? Because we actually are in a competition internationally. And this is not a competition for who makes more dollars. This is a competition for what nation state, what value system is going to determine how the next 50 to 100 years go. That's the competition. So we do have to work together in it. But the good news is we have the best universities in the world. The good news is we have an incredible talent pool. The good news is we have the most incredible piece of dirt on the earth to work with. Great. We just have to choose to work with it.
Yeah. Alex, always inspirational. Every time I'm with you, I walk away better. I would even say gooder. Yeah, on a day like today. So, folks, thank you. I know you love this. So please like this, share it, send this to a friend who hasn't been listening to Hangar X yet, and stand by for the summit we're going to be doing on modern skies. And there's also some announcements coming up that I think are going to be really exciting to our entire community. They're going to blow your mind. So we're excited about some things that we're going to be putting out there soon too. So keep knocking them alive out there.
Thanks, John.